Today I'm going to talk about some of the common mistakes people make in statistical model development or in data science model development. So the first mistake often people make is defining the problem statement. They wrongly define the problem statement. And if you do that, which is the first step in any modeling exercise, you will commit a number of mistakes thereafter, whether it is the choice of methodology, whether the way you interpret results, all that is going to be not very useful if your problem statement is wrong. Only if you have clarity about the problem and what you are trying to solve, only then you will be able to know whether you want to use a supervised learning algorithm, unsupervised learning algorithm, whether you will take the econometric statistics approach or the machine learning approach. Do you want to just do the prediction, or do you also want to understand the relationship between dependent and independent variables? Unless you have clarity about those things, you won't be able to build a good model. So having clarity about the problem that you are trying to solve is very important. Right? Otherwise you will end up in a mess, and whatever you do after that is of no use. So that's the first thing to note. If you do not understand the problem statement, go and do your research and then you start your modeling exercise. You should not straight away go and do modeling. That is going to be difficult. First, understand the problem. Talk to people. Talk to your supervisor. You are doing if you are doing research. If you are building models in industry, talk to your managers. Talk to the people in the business. Just try to understand their own requirements. Only then you will be able to formulate the problem properly, and data collection modeling comes much later. Don't straight away go and build models. That is going to be of not much use. Okay, so that's the first issue. The second is related to the sampling. What people do is that they use completely non-representative sample and build models and then use it in production and see that the results are totally different from what you was expecting while building the models. That's because the sample that you have used for model development is not representative of the population. So to ensure that the sample that you use is representative, you do all kinds of tests, right? You ensure that the sampling is random sampling or stratified random sampling. You do all kinds of checks. You check the summary statistic between the sample and the populations. You talk to the users of the models to see whether they do recognize this as a representative sample or not. You test the sample qualitatively as well quantitatively to ensure that the sample represents the population. Only when you are sure about that, then modeling makes sense. If you are using a wrong sample, it will only give you wrong results. It may work fine in the training data set, but it won't work fine later on. Now people often make this mistake that they define the training and test data set from the sample, and then once the performance in the test data set is fine, they're sure about its performance in the production. That may not be the case because you have chosen the wrong sample at the first place. So even with a good score, a good accuracy score in the test data set, it's still going to fail in the production. Okay, so very important to do proper sampling. The third mistake that people do is not ensuring that the quality of the data that you use is sufficient. It is of good quality. As they say, garbage in and garbage out. If you use garbage data of not so good quality, the results of course will not be of good quality. So ensuring that the quality of the data is good is very important. If the quality is not good, it is better not to do any modeling, because whatever comes out of your models is not trustworthy. So no point in wasting time. So rather spend your time in remediating the data, making the data better, right? That should be where you should be spending your time on. If you're working in the research area, data quality often is good, but in the industry, data quality is a mess in many organizations. for a variety of reasons, for legacy issues, for long data hasn't been given enough importance, and for a lot of, for a long time people used to think that there's a waste of time to maintain good quality data, and because of that there's tons of issues in the data. So first you need to remediate the data, spend time to correct the data, and then start building models, and also give importance to sampling and other things that I've already spoken about. But don't overlook the quality of the data. You will end up in a mess after you implement the model. Okay. Misuse of some of the inferential statistics techniques used in the field of statistics. For example, the use of p-value. What people do often do is that they misuse the p-value for their own benefit. This is a very interesting topic in the field of academia. In many academic research, whether in medical science, pharmaceutical science, social science, economics, and also in some hard sciences, people misuse the p-value, and they use it for their benefit. Just, they have a preconceived notion about the results, and then they use p-value to justify that, right? And they sample in such a way that the p-value is is meeting the required threshold to be called as significant, and then using that to justify result. That's a lack of academic integrity in my view. In some academic disciplines these things are punished very well, so people tend to rectify that, or they don't dare to even do that. But in some of the other academic fields, such as in social science, in some of these social sciences such as psychology, sociology, in these fields, p-value is misused quite a lot. It's also misused in the industry, especially in the banking and financial service industry. People do all kinds of things, such as ensure, how do you select a set of input variables in models, or the risk drivers in the banking and financial industry. A lot of time they use based on p-values, significance level, and there a lot of people make mistake. If they have preference to include some of these input variables, or the independent variables, they use the p-value, but they know that there's something wrong with this, because your selection of the sample, or maybe other way, they will try to ensure that there is a bit of a manipulation indirectly they can do in the p-value, and hence that variable will be included in the model. Totally wrong. You should not do that. Lack of that's absence of, or lack of academic integrity, in my opinion. The next mistake people make is the lack of robust validation. It goes without saying, validation is super important in model building, whether in statistics or in machine learning. It doesn't matter whether you are doing academic models, or models in industry. Validation is super important. If you don't validate your model in different kinds of data sets, you will never be sure about whether the performance will be good in production. Okay. And the mistake people make is that they validate just once in the test data set, and sure that this is going to work. That's not the case. You have to do all kinds of validation, out of sample validation, out of time validation. You need to do all kinds of use all kinds of validation techniques, such as all kinds of cross validations techniques that you have. Okay, whether bootstrapping, whether the k-fold cross validation, there are number of them, right? Try out all of them and see whether the model is performing well, even after using all these kinds of different cross validation techniques or not, just to be sure, right? It doesn't cost you a lot of money and time to do that. So the more you do, the better chances of the model performing well, not performing, but to ensure that the performance is consistent over time, right? uh, then the next mistake that people often make is the violation of some model assumption. It's quite important in the field of statistics, also important to some extent in the field of machine learning, where there are certain assumptions related to models. Many assumptions actually in the field of statistics. If you're building in quantitative finance models, there also you have tons of assumptions. So to check whether these assumptions are valid for the given problem is very important. Many people don't do that. In banking and financial, there are regulatory requirements to do that, so people really do that. They have to. There's no way otherwise the models will get approval. But in other industries where there are not regulators sitting on you to verify your work, people overlook these things. They don't assess the model assumption, go ahead with building models. It's very easy nowadays to build models because you import packages, everything is there. Build a model doesn't work in the real world. You really have to assess the countless assumptions you have for the models just to be sure. If some of the assumptions are too in like they're not remotely even valid, you have to be careful, take necessary measures for that. If some of the assumptions are invalid, it's not that you can't build models, it's just that you have to take mitigating actions in case something goes wrong. Okay, and assumptions could be assumption on normality, autocorrelations, independence. Well, there are many other assumptions. It's not like there are model specific assumptions. So some of these are common assumptions in statistics, but there are many more assumptions in modeling. The next mistake that people do is not having a proper plan how to monitor the models, how to benchmark performance of models once they go live. This is often a case in industries which are adopting data modeling or machine learning or statistical modeling more recently, like probably in the last decade. For instance, manufacturing industries or some of these, like even consumer research industry, they were not using a lot of data analytics for a long time. They're certainly using some form of data mining, but not sophisticated statistical modeling. And what they tend to do is that they don't have a proper plan for model monitoring. They build the model, implement, but don't really know how to assess its performance over time. That causes a lot of issues. This is a requirement in banking and finance, that you really need to monitor the performance of your models properly before you are sure that you can use it for next 1 year or next 2 years. If the performance is not satisfactory, you need to redevelop the models, and that is done periodically, sometimes quarterly, half yearly, or annually. That is a must thing to do. So every time you build a new model, make sure you have a proper plan in place. How often you assess model performance? It can also be automated, right? You can write some script to get the model performance on a regular basis automatically. You don't have to do it manually. So these are some of these issues that people make while building data science models. If you have come across other types of issues, please do comment in the comment section. And if you want to reach out to me for anything, please do that. Comment on this video your experience of building models and what are the other issues that you have faced while building these models. Thank you, and see you in another video.